Everyone, let's start this session to know about the processes and how does an operating system views it, which is a topic under process management. So we have OS view of process, that is how does an operating system view a process as. For an operating system, a process is nothing but an execution of a program. So to realize this view, the operating system will create the process, schedules them for the use of the CPU and terminates them. Therefore, to perform the scheduling, the operating system should know which process requires the CPU at any moment. For this, it uses the concept of process state so that it can keep track of what a process is doing at any moment. When a process is scheduled, the CPU will keep on executing the instructions in the program. Once the CPU is switching to the other task or nothing but to the other process, the kernel will save the state of the CPU and this state will be reloaded into the CPU when the process is scheduled again. So we say a process is comprised of 6 components. They are ID, code, data, stack, resources and CPU state. So ID we have said it is a unique name, like it's like a unique name or ID we are assigning to the program execution. Code is nothing but the program what we are writing. Data is your data and the files which are used in the program's execution. Then the different kind of resources which are allocated by the operating system, and the stack. The stack contains the calling the procedures and the return addresses. And next we have CPU state. The CPU state, it will contains the informations like address of the instruction which has to be executed next, then the condition code which is also called the flags, and the contents of the CPU registers which are all will be there in the CPU state. The CPU state will be changed as the program execution proceeds. The code, data and stack of the process constitutes its address space. Next we have controlling process. In the controlling process, we say that the process will be using the CPU when it is scheduled, right? It also uses the other resources, like it may be system resources like memory, or it may be user created resources like files. Therefore, the OS view of a process consists of 2 parts. One is the code and data. The code and data areas of the process, including its stack and resources allocated to it, and the second one is information concerning program execution. So this is a general environment, nothing but a controlling of process is. How does an operating system views the process as? So here we say there are 2 parts. Process is viewed by an operating system. One is the process environment and the other one is process control block, nothing but PCB. So when we say a process environment, it is also called as process context. So this environment contains the address space of a process, that is its code, data and stack and all the information which are necessary for accessing and controlling the resources allocated to the process. The OS will create this process environment by allocating memory to the process, loading the process code in the allocated memory and setting up its data space. So these are the components which are used in process environment. The first one is code and data. So code and data, already we have said code is nothing but the program what we are writing, and the data is nothing but the input and the data files what we are using, including the stack also. Next we have memory allocation. So memory allocation is nothing but the information concerning memory areas which are allocated to the process. So this information is used to implement memory accesses made by the process. Next we have status of file processing activities. Status of file processing activities, nothing but the pointers to files opened by the process and current position in the files. Therefore, so what are the different files which are opened by the process, we need a pointer to state it. That is what we have saying status of file processing activities. Next we have process interaction information. They are nothing but all the information which are necessary to control the interaction of the process with other process. Example, inter-process message, right, or IDs of parent and child processes. Next we have resource information. So this is the information which are concerned about resource allocated to a process. Next we have miscellaneous information. So miscellaneous information, nothing but the information which are needed for interaction of a process with the operating system. Was about your process environment. Next we have process control block, nothing but PCB. So this PCB is a kernel data structure that contains information concerning process IDs and CPU state. Therefore the kernel will use the three fundamental functions to control process. One is scheduling, the next one is dispatching, and the next one we have context save. So scheduling is nothing but selecting the process to be executed next on the CPU. Dispatching is nothing but you are setting up the execution of the selected process on the CPU. And next we have context save, nothing but you are saving the information concerning to a running process when its execution is suspended. Maybe it is preempted or maybe it is suspended. So here this is the general representation what we have for process control block PCB. So next you can see here we have an event, then we have context save, event handling, scheduling and dispatching. So event is nothing but a change in a state. For example, you are running a process and suddenly interrupt occurs and you may need to change your process to the next one. So that is nothing but change in the state of a process, nothing but your event. Once the event is occurred, then you can say that your related information has to be saved on the CPU, right? That is what context save. Then you will say what are the kind of event you need to handle, that is event handling. Then we have scheduling. So now you have to allocate your CPU, so to which process you need it, then you have to do the scheduling. And dispatching is nothing but setting up the environment for the execution of your process. So this is your process control block. So here when we say the operating system views the process as an execution of a program. So execution of a program is nothing but the CPU will create the process, right? It schedules them for using the CPU and terminates them. So how it has to check out, like what is the process you are using, how to schedule the CPU, and once the execution is done you have to terminate them. Therefore the OS will have two kind of blocks. One is process environment and the other one is process control block. In the process environment we will say about code and data, memory allocation information, status of the different files which are opened by the process, then the process interaction information we have, and the different kind of resources allocated, and miscellaneous information like the interaction of a process with the operating system. Similarly with the process control block, nothing but PCB, it will have mainly three criteria. One is scheduling, dispatching and context save, and this is the general representation. So based on the event, nothing but the change in the state, you will you will save the changes on the CPU, then you will check out what kind of event you need to handle, you will schedule them, and you will set up the environment for the execution of that particular process.